This is chapter 1 of the Larson Pre-Algebra by Holt McDougall, and I will go through the first chapter in this video, starting out with section 1, okay, and we have to evaluate the expression when x equals 6, and from prior knowledge, your expression is x plus 6. There's no equal sign. It's not an equation. It is an expression because there is not an equal sign. Okay? So what we are going to end up doing here is it's telling us x equals 6. So every time we see an x, we're going to plug 6 in. So this problem is going to read 6 plus 6, which equals 12. Down here, and I have a small mistake. I'm going to erase that and put your x in there. Okay, so it's 12 divided by x, and x is 6, so we are going to go 12 divided by 6, which is 2. And I may ask you to open up your textbook, and I'm going to do that right now, as Expressions and Variables 1-1 is the chapter that we are on. And as you can see in there, there are some vocab terms that are highlighted in yellow for you. Okay, you need to write those down in your notebook and write down a definition for them. Okay, and if you turn to page 5, I will give you about 10 seconds here to do that now. I'm going to use these problems that are up here on the board to kind of go through what these terms actually mean. So the first one is a numerical expression. And a numerical expression consists of numbers and operations. Okay? This is a numerical expression, and I'm going to circle that in blue. All right? It consists of a number and a letter and an operation of a plus sign, okay, which means addition, obviously. And the x is what we call a variable. Okay? A variable is a letter used to represent one or more numbers. Now, if we have a variable expression, and I'm going to back up there for a second because we have a numerical expression and we have a variable expression. This is not a numerical expression. Okay, this is what we call a variable expression. So that's my mistake on that. It is a variable expression because it does have a variable in it. Okay, a variable expression consists of numbers, variables, and operations. Now, the numerical expression, and I'm just going to put that up here quickly on the side. A numerical expression would simply look something like 2 plus 4. Okay, all that consists of is numbers and operations. All right, 2 plus 4. So quick fix that there in your notes if you did write that down. Okay, now the word evaluate. Okay, evaluate the expression. What that means is you're going to be given a number and you have to put it in to the variable. Okay, and then basically you're solving. So let's take a look at the second screen. Okay. Evaluate the expression when x equals 4 and y equals 2. All you're going to do is take 4, put it in for x, take 2 and put it in for y. And this dot means multiplication. And when we multiply, we get 8. Okay, and here, y is 2, x is 4, and it says to subtract them, okay? And this might be a little bit ahead of you, not sure what the background you've had is, but if we take 2 minus 4, we do end up with a negative 2, okay? And we do have a section down the road here coming up where we will add and subtract positive and negative numbers. your next slide, okay, you need to turn your books to page 6. I'll give you a couple seconds to do that. And as you can see on page 6, in the middle of your page, it does say common words and phrases that indicate operations. So you have words that mean addition, words that mean subtraction, words that mean multiplication, and words that mean division. All right, I would copy those down in your notebook, and if you need to pause the video to give yourself time to copy those down, do that now. All right, now coming back to this, you should have written down the words that mean some sort of operation, okay? And if we get into this first statement, it says the difference of a number and 4, all right? Difference is important. And if you look at the column of words that you just wrote down, difference is under subtraction, okay? And we have difference, and when you see the word of, we have a number and 4. So that is the difference of a number and 4. It doesn't matter what variable you use, okay, as long as you use a variable. And down here, the word is product, the product of a number and 3. Okay, these are important. A number and 3. So we have n times 3. And usually when we want to write something mathematically correct, okay, we would flip this around and put the number in front of the variable. That number can also be called a coefficient. That is not in your book, but it is something that you will learn in algebra. Okay? So, we have come to your first assignment. All right? Please do your assignment on a separate sheet of notebook paper. At the top of the paper, please put your name, the date, and what the assignment is. Do not lose your assignments, as I will be collecting these as we go along. You may now pause the video or turn the video off and do your homework. Okay, welcome back to the section 1.2, which is powers and exponents. Once again, we are still in the Pre-Algebra Holt-McDougall textbook. And the first part of this section starts out talking about some terminology. And your terminology is going to be on page 10 in your book. And there are 3 words: power, base, and exponent. Okay? If we have a number with a smaller number up top, okay, which can either be called a superscript, or it is what in the math world we call that a power or an exponent, okay? It is going to tell us the number of times we are going to multiply what we call the base. Our base number is 4, our exponent is 5. So what this means is we are going to take 4 times itself 5 times. As you can see, 1, 2, 3, 4, 5. There are 5 4s, okay? And this is what we would call expanded form. And if they wanted you to evaluate that, you would take 4 times 4 times 4 times 4 times 4 and come up with an answer, if they wanted you to evaluate it, okay? So, this part right here, they are giving you the expanded form, and they want you to write it as an exponent, okay? Well, the number that is written out here, that is your base, all right? So we start with our base. And then, how many 5s are there? There are 3 of them, okay? So your base and exponent is 5 cubed. The next one is 1.2. Well, this can be a little confusing when you have dots in there. You may also see it written with parentheses. Okay, that also means multiplication. So we have 1.2 and we have it 4 times. So your base is 1.2 and your power is 4. And go ahead and pause the video anytime you need to Copy these problems down in your notes as you go along. So now we're back to the word evaluate. Evaluate the expression when x equals 3. Okay? Remember in the first section when we had evaluate, we took 3 and we plugged it into the variable. So here we have x to the 4th. Well, x is 3, so I'm going to go 3 to the 4th. And if I expand that out, that is 3 times itself 4 times, and it does want me to evaluate, so I need an answer. If I simplify this, that equals 9, and that equals 9. 9 times 9 is 81. So there I have evaluated the expression. This one down here is 3 squared, okay, which is 3 times 3, which is 9. The only thing I would like to show you on this is if we had a negative number, say it was to the 3rd power, we do have to take the negative with that number. So we would write negative 4 times negative 4 times negative 4. You may also see it using parentheses. And the only thing I want to tell you is we haven't gotten to positive negative numbers yet, but just so you know that if there is a negative with the number, we have to multiply the negative with. Okay, I'm not going to finish this because we are not to that part in the textbook yet. You have now reached your assignment for section 2, powers and exponents. Go ahead and copy down your assignment. Remember to put your name on your paper. Please start a new paper or a new blank page in your notebook, and do not lose your assignments from previous, as I will be collecting all of them at the same time. This is section 1-3, which is on order of operations. Okay, order of operations is very important because to evaluate expressions involving more than one operation, you have to follow a set of rules, which we call the order of operations. Your order of operations, the first thing you have to do is you have to evaluate all expressions inside what we call grouping symbols. These grouping symbols can be parentheses or brackets. So the first thing you have to look for when you evaluate is you have to look for parentheses, and you have to work inside the parentheses first. Okay? Then you look for exponents, and you have to evaluate the powers or exponents. Thirdly, you multiply and divide left to right, and we'll talk about that here in a second. And then you have to add or subtract left to right. So let's talk about the multiply and divide problem. Okay, if I was given, let's say 12 divided by 6 times 2. Okay, now these work on the same level. So just because division comes first in my statement doesn't mean I or doesn't mean that I have to go and do multiplication first. Okay, because multiply is before divide here, but because they're on the same level, we just work left to right. Okay, so 12 divided by 6 is 2, and we still take it times 2, which is 4. Okay, now if I did multiplication first, and I'm going back up to the beginning, but if I did multiplication first, I would end up with 12 divided by 12, because 6 times 2 is 12, and I would get 1. I get two totally different answers. So you have to be careful. If multiplication and division are on the same level, you just work left to right. It does not matter if multiplication comes first in the list, all right, and in this case division came first, so we work left to right. We do division first and multiplication second. The same thing holds true when you get down here to adding and subtracting. All right, if adding and subtracting are the only two operations, and subtraction comes first, you have to do subtraction first. So let's look at some examples. Okay, here we are going to evaluate, and if you follow your list of order of operations, which you should have copied down in your notes. Remember, if you need to pause the video to give yourself time to copy down what is on the board. Okay, and if you look at your parenthesis or your order of operations, and going back here, the way you can remember that is PEMDAS. PEMDAS, and there are several sayings to help you remember that. The one I use is please excuse my dear Aunt Sally. Okay, that's how you remember your PEMDAS. So going back here, and the first thing that comes first from top to bottom is division. All right, so we have to take 63 divided by 7. Well, if you know your math facts, that is 9, and we still bring down everything else. 28 minus 9, and we should arrive at an answer of 19. Okay, next problem. Now, this is 52 plus 12.5 times 4. Okay, multiplication comes first, top to bottom in the PEMDAS. So I'm going to multiply 12.5 times 4. You may have to come over to the side and do a little bit of side work. Okay, so 5 times 4 is 20. It's a 10, 4, 5, and I have one number behind the decimal. I have to have one number behind the decimal there. So I have 52 plus 50.0. All right, and I can disregard that decimal point and that's 0, so I should end up with an answer of 102. Okay, your next problem. And here, as you can see, I do have some multiplication, I have addition, and I have division. Okay, luckily they are separated by a number in the middle. So what I am going to end up doing is I'm going to multiply 9 times 6, and I know that is 54. Okay, I also have a division in the back. 27 divided by 9 is, or 27 divided by 3, excuse me, is 9. And I'm going to bring down my plus sign, okay, because that does not go away. And now I add them together to get 63. Okay, here you're given a set of parentheses. This also means multiplication, okay? But because parentheses comes first, top to bottom in your PEMDAS, you have to look inside the parentheses and simplify that expression first. So we have to do 1.5 plus 0.6, and we arrive at 2.1. So we have 10. It still stays in parentheses because this means multiplication. Okay, so I need to take 2.1 times 10. And if you know your multiplication, when you multiply by 10, you have to move your decimal one place to the right, and you arrive at an answer of 21. Okay, here's your next problem. And this one can be a little bit confusing to try and remember. The only thing you have to remember about this is you have a group on top and a group on the bottom. And so if you need to rewrite this, you can. So that it looks like that. Okay, so now you do have two separate sets of parentheses, okay, and this should give you, if we take 70 minus 9.2, we should end up with 60.8, I believe that's correct, and we divide that by 8. Okay, and now I'm going to do some side work over here. I'm going to take 60.8 divided by 8. 8 goes into 60 7 times. Subtract going down. Bring down the 8. Remember, your decimal point goes straight up. 8 goes into 48 6 times. And so your final answer is 7.6. If you need to pause the video to copy this down, go ahead. Okay, here's your next problem. Now, if you notice what we have up here, we have division, we have subtraction, we have multiplication. Okay, we also have what we call parentheses, and we have brackets. You treat the brackets just like parentheses. So we want to start inside the brackets. and looking inside the brackets, we have parentheses. So we're going to do that first. So I rewrite everything down. I still have my brackets. 11 minus 7 is what I'm doing first. That is 4. And I can get rid of those parentheses because everything's still going to be inside the brackets. Okay? This is still your grouping symbol. These are still like parentheses. You have to do this first. So 72 divided by 2 times 4 is 8. And then 72 divided by 8 is 9. Okay? So just kind of a layout of a problem that you may run into brackets here later on. Okay, here's your next problem. Now you are back to the word evaluate. Okay, it's telling you what x and y is. The first step you have to do is you have to plug in your 4 and your 2. If you have a y, well here we only have x. Okay, but we have to plug in what they give us. So we rewrite the problem, 1.2 and 4 plus 3. Once again, inside your grouping symbols first. So you're left with 1.2 times 7, a little bit of side work, multiply, and I have one place after my decimal, so I need to have one place after my decimal down there. So your answer is 8.4. Now, what I need you to do is please write this at the top of your paper so that you remember x equals 4 and y equals 2, because you are going to use that on the next page. Okay? Now, on this one, we do not have our parentheses. So, we're going to take 1.2 times 4 and plus 3. And I always, when you substitute a number in, like we're doing here, we're substituting 4 into x, use parentheses. That will help you. It's a good habit to get in because it will help you down the road. Okay, so here we have multiplication. Remember, when we have a number in parentheses, that also means multiply. We have addition. By rule of order of operation, we have to multiply first. So we end up with 4.8, and we still have plus 3. And when I put that together, you end up with 7.8. Okay? Once again, we need to remember x equals 4 and y equals 2. Okay? Go ahead and plug it in or substitute in. Remember, there's an x. I need to add a parenthesis. There's my y, I need to add a parenthesis, and now I can evaluate. I have two multiplications with a subtraction in the middle. 3 times 4 is 12, 2 times 2 is 4. I'm going to subtract those, and we get 8. Okay, once again, x equals 4, y equals 2. Alright, so we have 0.5, a bracket, 2 minus parenthesis, 4 minus 2, closed by a bracket. And this is just like the problem we had earlier. We have brackets, and inside brackets we have parentheses. We have to do this first. Alright, so I'm going to copy everything back down. And here, this is 4 minus 2 is 2. Okay. Now we work inside the grouping symbols, which happens to be brackets this time. I still have 0.5, 2 minus 2 is 0, and anything times 0 is 0. Go ahead and pause the video if you need to copy this down. Okay, once again, x equals 4, y equals 2, and now we're given a power, so we have 4 squared minus 2. X is 4, y is 2, substitute them in, and now go ahead and solve or evaluate. 4 squared, remember that is 4 times 4, minus 2. 4 times 4 is 16, minus 2 gives us 14. Okay, another one. First thing we do is we substitute x and y in. Okay, and now this one we have to be careful on because we do have a power of 2 on the outside, but by order of operation we have to do what's in the parentheses first. So 4 minus 2, we do that first, and that's 2, and we also have 2 squared. Now, we did parentheses, next is exponents, okay? So we have to do 2 squared. Well, 2 squared is 2 times 2, which is 4. So we have 2 times 4, and we end up with an answer of 8. And now we have arrived at the end of the section 1-3, order of operations. You may copy down your assignment. Remember to put your name on your page and the assignment at the top of the page, and go ahead and get started. Okay, we are now on section 1-4, comparing and ordering integers. If you turn your books to page 22, you will see a couple definitions. One of the definitions that you will see in there is what we call integers. And there's also a number line, kind of similar to the one I have on the board. Okay, integers are your numbers that are positive and negative. And these number lines go on forever, so it doesn't only stop at 6, it goes 7, 8, 9, all the way to what we call infinity. And this is going in the negative direction. Now notice that as you go to the left, the numbers themselves are getting bigger, but because they are negative, they are getting smaller. Okay, so a -6 is smaller than a -3 because it is further to the left on the number line. So as you go left, we get smaller. As we go right, we get bigger. Okay, and once again, you do have some definitions in your book on page 22. Okay, so now we are going to work with what we call absolute value. Okay, absolute value, and this is on page 23 up at the top if you want to copy down your definition and your term, go ahead and hit pause now and copy that down. The absolute value of a number is its distance from 0 on a number line. And these are what we call absolute value bars. So the absolute value of 5, if I go to my number line, okay, there's 5. And the absolute value is found by how far or how many units is it from 0 to 5. And on this one, it is 5 units. So your absolute value is 5. And if you can remember, absolute value is always positive. So if we look down here, we have the absolute value of a -7. -7 on your number line is right there, and you're checking to see, okay, how many units is it between -7 and 0? Well, it is 7 units. Keep in mind, that is always positive. It doesn't matter if it's positive or negative inside the absolute value bars, your answer is always going to be a positive number because it is strictly talking about distance, the distance between. When we drive in a car, and if we were to say you're traveling right on a map, okay, you're traveling a positive distance. If you travel left on the map, you're still traveling a positive distance. Okay, you're not traveling -10 miles or -35 miles from here to Devil's Lake. We say we drive positive 35 miles, similar to absolute value. Opposites. And opposites are very easy. If I had a -3, what is the opposite of -3? Okay, well, it's going to be a 3. These are opposites of one another. One of them is positive, one of them is negative. The only other thing you have to remember is how far is it from -3 to 0? Well, it's 3 units. So the opposite of that is going to be whatever number is 3 units in the other direction from 0. Okay, so opposites are easy. One of them's negative, one of them's positive. And now we're back to evaluate. Evaluate when x equals a negative 4. Okay, the first problem. We have a negative x. So we have to have that negative first, and then once again, use parentheses when you substitute a number in. So we have a negative, parenthesis, negative 4. Well, somewhere along the line, hopefully we learned that 2 negatives equals a positive. And we'll get to that when we do adding and subtracting as well. But 2 negatives equal a positive. Or you can back up and think of that as a negative 1 times a negative 4. And once again, we haven't done positive negative numbers yet, but a negative 1 times a negative 4 is 4. Okay? Down here, we have 12 minus the absolute value of a negative 4. Well, we just learned that the absolute value of any number is positive, so we have 12 minus 4, which gives you 8. Okay? The trick is you have to remember that your absolute value is always positive. And notice how I do these problems, okay? I just work top, my next step, my next step, my next step. I would really like if you would do that in your notebook the way that I am showing you on the board. It keeps things clean. Remember to skip a line in between problems. Okay, here's your next one. And once again, x equals a negative 4 from the previous slide. We have to remember that. So we have a negative 4, the absolute value of that, plus 9. The absolute value of a negative 4 from the previous slide was positive 4. 4 plus 9 gives me 13. Down here, same thing. Absolute value of a negative 4 minus 1. That is 4 minus 1, which is 3. Pause the video if you need to copy these problems down. Okay, here's your assignment for the end of section 1-4 on comparing and ordering integers. Remember to put your name on your paper, copy the assignment down, put it at the top of your page, and do not lose any of your assignments. Okay, we are now going to 1-5, adding integers. And we've done a little bit of this already, just, without knowing the rules. A couple of problems we've had in the previous sections involve this. So hopefully after this section, you will know how to use your rules and apply them to add and subtract, because the rules are, fortunately for us, the same. So what you need to do is push pause on your video and copy this down, okay? And then we will talk about them here in a second. All right, we now have some rules here for adding and subtracting integers. The first one is same signs. And if you have same signs, like positive and a positive, you add and you keep the common sign, okay? Examples of what same signs look like. We would have, say, 5 plus 4. Now, this 5, growing up in math, we know that that number is positive. So we know that there is a plus sign there. We also know we don't have to write that plus sign down because it is known that it is a positive number. So that is an example of two numbers that are positive. We add them, and 5 plus 4 is 9, and the common sign, they're both positive, so we would have a plus 9. Now remember, we do not need that plus sign, so we don't have to write it up there, but I just wrote it up there to show you. Okay, well, what does it look like if we have same signs and they're negative? And I know I don't have a lot of room here, but, okay, well, what if we have this? They're same signs. Yes, this is a subtraction, but we also treat it as a negative. So we have two negative signs. We have a -6 and a -4. Your rules say add the numbers, or add and keep the common sign. So 6 plus 4 is 10, and the common sign this time is a negative. So you're going to have a negative 10. Very simple if you follow your rules. Okay? Different signs. We subtract, and when you subtract, we always take the big number minus a small number, and then we're going to keep the sign on the bigger integer. So, for instance, let's say we have 5 minus 10. Okay? Well, first of all, this 5 in front here, we know that is positive. Okay? My signs are different. I have a plus sign. I have a negative sign. Remember, this is also a subtraction sign, but it is also a negative sign. Signs are different. So what I'm going to do is I'm going to subtract. I'm going to take the big number minus a small number. The big number is 10. The small number is 5. When I subtract 10 minus 5, I get 5. Now we have to continue reading in our rules. We keep the sign on the bigger integer. Well, 10 was bigger, 10's bigger than 5, and the sign on 10 is negative, so my answer is a negative 5. I have to take this negative sign, because it's on the bigger number, and apply it to my answer. Okay? Now, one last thing, I did also write this on here. You have to always have one sign in front of every integer before using these rules. And go ahead and push pause if you need to copy that down right now. Okay, so here we go. Going by your rules, we have a negative 41 plus 26. Signs are different, so we have to subtract. Okay, just a little bit of side work. I'm going to subtract 41 minus 26 is 15. Okay, come back over here. So my answer, part of my answer is 15. Now I have to go back and look, what number is bigger, 41 or 26? Well, 41 is bigger than 26. Okay, don't worry about the signs. Worry about the numbers themselves. Okay, 41 is bigger than 26. What is the sign on 41? It is a negative. So I have to take that sign and I have to apply it to my answer. So my final answer is a negative 15. Okay, down here, I have, actually I have 3 signs this time. And remember the rule I wrote on the board, the last thing was it said, get one sign in front of each number. Okay, well, we know we don't have to have a plus sign in front of a number because we know that that number is positive. So when you have 2 signs like this, you get rid of the plus sign. Okay, and I'll see if I can squeeze that in without erasing too much. So now we have a new problem of negative 19 minus 11. Well, if you look at these 2 signs are the same. Go back to your rules. Read what your rules say. Your rules say add the numbers. 19 plus 11 is 30. And then it says keep the common sign. The common sign is a negative sign. So I have to apply my negative sign to my answer. So I get a negative 30. Now I have 3 numbers, okay? The easiest thing to do here is simply work left to right and solve 2 of them at a time. So I'm going to work with these 2 numbers right here. I have 52 plus a negative 30. And from the previous slide, I told you we could get rid of that plus sign because that plus sign we do not need. So now I am at 52 minus 30. And don't forget, we still have this other information that we have to bring down when we are done. 52 minus 30 is 22. Okay, and now I'm going to bring down what else I need to bring down with it. Okay, so now I have 22 plus a negative 46. Basically, you did 2 problems in one. All right, we don't need that plus sign. Oops, so I'm going to rewrite this as 22 minus 46. And remember, what sign is in front of that 22? It's not there, but it is known that it is a plus sign. These 2 signs are different. They are not the same, they are different. So we have to subtract. A little bit of side work. We take 46 minus 22 and arrive at 24. Now remember, I am not done. Okay? I have to go back. Because I subtracted, my rule also said that I have to take the sign from the bigger integer. Well, what number is bigger, 22 or 46? Hopefully you said 46, because 46 is bigger than 22. The sign on 46 is a negative sign. So we have to bring that negative sign and attach it to our answer. And we end up with a negative 24. Okay, just a couple more problems here to work out with addition. And I'll just quickly go through these. Feel free to push pause whenever you need to. Copy these problems down in your notes. Work them out on your own. I don't care how you do it. Okay, just some more for understanding. Once again, I can get rid of that plus sign. So I'm looking at negative 18 minus 8. Signs are the same. I need to add. When I add those together, I get 26. The common sign is a negative sign. So I get a negative 26. Down here, once again, I can get rid of that plus sign there. 32 minus 18 is 14. Couple more. Signs are different. I need to subtract. So once again, I take 11 minus 9, and I get 2. So my answer is 2. But I also need to go back and look at what sign I'm going to take. 11 is bigger than a negative 9, or excuse me, 11 is bigger than 9. The sign in front of 11 is positive, so it's a positive 2. I do not need to put the plus sign in front of a 2, because if it does not have a sign, it is known to be positive. Your next problem is 15 plus a negative 7. Once again, get rid of that positive sign. You do not need it. We're at 15 minus 7, which is 8. Okay, here's your assignment for adding integers. Go ahead and put your name on top of your paper. Start a fresh new sheet of paper. Skip a line in between problems. Make it as neat as possible. Do not lose your other assignments. We are now moving on to 1-6, which is subtracting integers. Luckily, the nice thing for us, our rules that we wrote down in the previous section for adding integers is going to work exactly the same as what we are doing for subtracting integers. So you probably want to pull out your notes and take a look at those as we go along, unless you know the rules by heart already, which is fantastic. Okay, so first problem. Once again, this is positive 2. Signs are different. When the signs are different, we have to subtract. So I take 6 minus 2, which is 4, okay? And I take the sign from the bigger number. What number is bigger, 6 or 2? 6 is bigger. The sign that is in front of 6 is a negative. So I need to apply that to the 4, and I end up with a negative 4. Okay? Now, the next problem is one we have not really seen before. We do have 2 signs in front of 8. Luckily, those 2 signs are, or not luckily, different. Okay? Those 2 signs are both negative signs. The rule you have to remember is 2 negatives equal a positive. So what I'm going to do with these 2 negative signs is I am going to make one big plus sign out of them. So now I have 3 plus 8. Well, 3 plus 8, simple math, is 11. So anytime you have 2 negatives, make a big plus sign out of those. Okay, here we have same signs. What we do on same signs, we add them. 7 plus 4 is 11. And both signs are negative, and so I need to bring that negative sign over for my answer as well. Okay, next problem. Here we have a negative 1 minus a negative 13. Once again, from the previous slide, we have 2 negatives, which we need to change to a positive. And if you need to rewrite that as a step down below, go ahead. Signs are different, so we're going to subtract. 13 minus 1 is 12. 13 is bigger than 1, and the sign on the 13 is positive, so my answer is a positive 12. Here's another one. Same signs, we add. 14 plus 3 is 17. We keep the common sign. Both of those signs are negative. We end up with a negative 17. Same thing as we had before. Two negatives equal a positive. Add those numbers up. You should end up with 39. Couple more problems. Same signs. We add. And if you want to do this before you watch the video, push pause now and solve these two to make sure you know or you have an understanding of what you're supposed to be doing. Okay? Same signs we add. Common sign, negative. So you end up with a negative 24. Okay? Your answer for this one, combine those two negatives to a positive, and now I have a negative 9 plus 14. Once again, my signs are different. I need to subtract. 14 minus 9 is 5, and 14 is bigger than 9, and the sign on 14 is positive, so I would end up with a positive 5. Once again, I do not need that positive sign. Okay, so it's very similar to what you did in the previous section. Your assignment is page 36, 11 through 47. Please put your name on your paper, put your assignment at the top of your page, and you may begin with your assignment. Alright, before you do start section 1-7, please visit Mr. Vogt to find out what your mid-chapter quiz is, and he will let you know that. So please do not start 1-7 until you have completed your mid-chapter quiz, and ask Mr. Vogt for that, as he will tell you what you need to do there. Alright, so we are now going to move on to 1-7, multiplication and division of integers. This is on page 42 in your textbook. And we also have two new rules for multiplication and dividing of integers. They are the same rules, they work for both operations. So, the first one, if you are multiplying and dividing, and your signs are the same. So for instance, same signs might look like this, negative 4 times negative 6. Alright, you simply multiply those two numbers, and if signs are the same, your answer is going to be a positive. So your answer is a positive 24. Another example would be maybe 5 times 4. Well, we've done 5 times 4 forever. You know, we just didn't know there was a rule that we specifically had to apply to that. If your signs are different, your answer is negative. Two simple rules to remember. Okay, different signs would look like that. A positive and a negative. Your answer is going to be a negative, whatever the two numbers multiply out or divide out to be. So I do have some examples. 3 times 12, 36, same signs, the answer is positive. Negative 9 times 7, I know my answer is going to be negative because I have a negative and a positive, so that means the signs are different. 9 times 7 is a negative 63. Negative 24 times 0, anything times 0 we know is 0. And 0 is neither positive or negative, so you just write down 0. Okay, next one. If you want to do these problems before I show you them, push pause now. Okay, here's your answers. Once again, two new problems. We are dividing now. If you would like to do them without me showing you first, please hit pause now. Here are your answers. One last problem. 24 divided by negative 6 is a negative 4. Here's your assignment. And some of your assignments might have some review problems from previous sections. Please put your name on your paper, start a fresh sheet of paper, put your assignment at the top of your page. Okay, we have our last section in Pre-Algebra Chapter 1, and this is on the coordinate plane. So, take out your notebooks, and I'm going to draw the coordinate plane up on the board. The first thing the coordinate plane is made up of is what we call an axis. And there are two axes, okay? We have an x-axis and we have a y-axis. All right. We also have a starting point, and a starting point, which is the red dot, is called an origin. The origin is where we start. All right. When we crossed these two axes, okay, they form what we call quadrants. Quad meaning four. There are four quadrants. And we label the quadrants 1, 2, 3, 4. We start in the top right and we go counterclockwise. 1, 2, 3, 4. We also use what we call Roman numerals to denote the quadrants. Okay? Now, within this coordinate plane, we can plot what we call points or ordered pairs. All right? So, we always start at the origin. Okay? And you're going to see ordered pair as x comma y. And if you want to look at this diagram and copy it down, you may push pause now. It is also on page 47. Okay, now x comma y. We always start with the x coordinate first. So we start on the red dot, which is the origin, and we have to go in the x direction first. All right, so I'm going to go to the next slide, and I have this up here. Let me get rid of that for us. Okay, so here's your x comma y, and I'm going to go in the x direction. This is x, this is y. Remember, your x-axis runs across, your y-axis runs up and down. So I'm going to go over 4 units to the right. So I start at the origin, 1, 2, 3, 4. Now I'm going to put a little x there. That's not my point, okay? But that's where I need to get to on the x-axis. Because x is positive going that way and negative going that way. And you always go left to right first, okay? So now I'm at 4 on the x-axis. Now I need to go a -1 on the y. Well, if I go up, that's a positive y. If I go down, that's a negative y. So 4 to the right and 1 down. So my point is going to be right there, and I'm going to label it point A. Okay? Your next one, we have a -2, 5 for point B. -2, so it means I move in the negative direction. So I'm going to start there, or that's where I'm going to move with my x, and then I'm going to go up 5. So 1, 2, 3, 4, 5. Make sure I'm lined up above my -2. Okay? And that's where I'm going to plot point B. Once again, point B is in quadrant 2, and point A is in quadrant 4. Here's your next one. And if you want to try them before you see the answer, go ahead and push pause now. Okay, -3, -2. I move left 3, 1, 2, 3, and -1, 2. There's my first point, which is point C. It is also in quadrant 3. 5, 4. I go right 5, 1, 2, 3, 4, 5, and then up 4. Somewhere in there. And it is point D. So we're just plotting points right now. Okay? Scatter plots. I'm not going to put a scatter plot on the board. You do need to go to page 48 in your textbook and read through example 3. Pay particular attention that a scatter plot is always in quadrant 1 and 0, 0 is in the bottom left. Usually when you see a table, the top row of your table is the x-axis, and the vertical axis, the y-axis, is usually the bottom section of your data table. Okay, so if you look at example 3 on page 48, the length is on the x-axis and the mass is on the y-axis. And pay particular attention to what numbers that they are using for this. In your homework assignment, if you do need to make a scatter plot, the graph paper is over underneath the cupboard. And you can go ahead and grab that and work on your scatter plots. Some things, just a couple other things with the scatter plot. You do have to plot points and make sure you have your labels on your x and your y axis. And this is your final assignment for chapter 1, starting on page 49 and 50. Go ahead and copy that down, put your name on top of your paper, also add the assignment, start a fresh sheet of paper, and make sure you have not lost any of your previous assignments. The next thing that we will be doing with this is you need to let Mr. Vogt know that you are done with section 1-8. You have completed chapter 1. You will now be ready for a short review and followed by your first test.